A good day to Professor Azman, Dr. Maria, and my fellow friends. So right now I would like to talk about detecting defects in mild steel plate welding via radiographic testing. But before that, I would like to give a brief explanation of radiographic testing, a part of NDT. So there is a radiation source with radiating beam towards the test specimen, and of course image quality indicator is placed on top, and below the specimen is a radiographic film that can accept the exposure from the radiation, and this film will tell if there is anything wrong with the specimen. But before we go deep into the defect, we have to understand why we use non-destructive testing to understand about this welding point, and this is because of the history of welding failure. For an example, UMM's headquarters is a 260,000 barrel tank explosion that causes 6 deaths and also $179 million in loss. And this is an example of welding failure that occurs at the tank propellant tank. Next, at Ekofisk, Norway, a cause of welding defect cracking, a laminar tearing of the structural integrity of the building caused the oil drilling platform to be capsized. And at July 23, 1984, Romeoville, US, a petroleum refinery disaster which caused by a cracking that exceeded 90% of the steel thickness, and this is because the welding a full submerged arc without a post-weld heat treatment. So we can understand, if we do not have a proper radiographic testing or non-destructive testing on this welding, we could have a failure which can cause to lot of money loss and even to death. Okay, so for now, we're going to talk about the occurrence of defect on the specimen, which is a mild steel with a dimension of 6 millimeter thickness, and the type of welding used in this case is gas metal arc welding with a wire electrode of ER70S-6, and the standard of welding is used is American Welding Society D1.3. Before we go talk about the defect, I would like to give an explanation of the technology in this welding, specifically gas metal arc welding. So we understand this technology is using the electrical arc between the base metal and the consumable wire electrode, which heats up to join the metals together, and the shielding gas is there to ensure there's no oxidation. However, the question is, why do we need to use this over gas tungsten arc welding? And this is because it is more faster, it has better effective on thicker metal, it is easier to learn than the typical GTAW, and this has cheaper component compared to gas tungsten arc welding, which is preferable to the industry. So we're gonna look at the common defect number one, the lack of fusion at the side wall. So lack of fusion is when the base metal and the filler metal is not bonded together, not fused together, and this is why this is something specifically occurred at the side wall, and this is important as it will make the metal joint weak. So the location of the defect, this specific defect, is at the side of the wall at the size of 1.125 mm, and the distributed of defect is along the welding line and caused by improper welding process. So we know that this defect is due to the process. And what is the specific cause? It could be the improper torch handling, such as the angle of the torch, too fast speed travel, and low either heat, not enough heat. And how to solve this is to reduce travel and wire feed speed, focus electrode on the edge of puddle, not at the center, but the edge of the puddle. Current has to be following the spec of 6 millimeter mild steel and also the specific proper wire electrode. Common defect number 2, splatters. As we realize, there is fine particle of welding metal flying over beside the target region, and this is considered as splatters. So splatters are just fine welding that is a defect in appearance of the metal base, and the location of defect is side of the weld joint or the surface of the base metal beside the welding joint. The size could be 0.12 millimeter for each splatter, and overall adding all of them together could be 3.6 millimeter. Distributed of defect is along the side of the welding point, and again caused by improper welding process. And defect is caused by the process, specifically because of the irregular stable arc, improper shielding gas, very high current, and a clogged nozzle. So to solve this, you have to clean the equipment such as the nozzle and check the welding wire to make sure it is proper length. Also must check the shielding gas pressure and regulate it properly based on the scenario, or based on this case, which is 6 millimeter mild steel. And also adjust the current based on the 6 millimeter mild steel as well. Common defect number 3. So common defect number 3 is the burn through, where there's so much excessive heat at a specific focus point, and this causes the metal to be penetrated and also metal sag. So as a weld joint, a smooth weld joint, you can realize that is metal weld sag at certain point, and this is easily occur at gas metal arc welding, and also because this mild steel is only 6 millimeter thick, so it is very much possible to occur. The location is at the weld line, but at a certain point of defect, and the size of defect could be 2.4 millimeter. In this case, is 2.4, and total in this case there's only 2 burn through, and total are 6 millimeter. And distribution of defect is at the point of where there's excessive heat, and in this case there's only 2, and caused by improper welding process, and that means defect occurrence due to the process. Specific cause is when the root opening is too large, the too slow travel speed, and too high voltage. And to solve this, you can increase the wire extension, making the heat do not focus, and increase travel speed again to make sure the heat does not focus at certain point, and also lower voltage based on the specification. Common defect number 4, hot cracking. So hot cracking is basically a cracking web flaw, which is typical in gas metal arc welding because of the temperature greater at 538 Celsius. Location of defect is along the welding line, and the size of defect in this case is 0.9 mm deep. Distribution of defect is along the welding line and caused by improper welding. Defect is occurrence of the process again, not the environment, and the specific cause is when the base metal has impurities, the welding bit is too thin, and the voltage is too high. To solve this, create the weld puddle at a specific size or appropriate size, and the proper filler metal have to be chosen based on mild steel 6 millimeter. Should not use incompatible filler metal, and you can use backfill technique. Welders can use backfill technique, which will help to make sure the joint of the welding is proper, strong, and crack free.